Welcome back, our dear learners, and thanks for always following and watching our lessons. This is lesson 30. Previously, in lesson 29, we introduced arithmetic progressions as one of the subtopics, as one of the types of series that we look at. We introduced arithmetic progressions. Now, when we introduced them, I said arithmetic progressions or any series is referred to as arithmetic, if the terms in it follow a certain systematic order. In other words, they sequence themselves arithmetically. For example, we are just making a review. For example, if you look at 2, 4, 6, 8, 10. To generate the next term after 4, we've added a 2 on the previous term. For example, from 2 to 4, from 4 to 6, from 6 to 8, and so on. You can see we are adding a certain what? Value 2. And if you try to get 4 and take off 2, you get the same result. You get 6 and take off 4. And it will be the same result if you get 8 and you take off 4. So this 2 here is what we called the common difference. We called this value here that is coming as our number 1 in the series, we call it the first term. And assuming we have 2 plus 4 plus 6 plus 8 plus up to 24, this 24 is called the last term. But I also said, if we don't call it the last term, it can also be called the nth term, because it can help us to determine other terms in this series. So, particularly APs, we talk A as the first term, we talk D as the common difference, Then we also talk about UN, which is A plus N minus 1D, or if we don't call it the nth term, it can be called the last term. Something very important there. If we don't call the nth term, we can all call it the last term, provided we are dealing with a finite series. If our AP is finite, it has got an end. That last term there is called, or it can be given by that, and can help us come up with all categories of things that we need. We may be looking for the value of A, we may be interested in the value of D, or else you can even be interested in the number of terms in such a series, which is arithmetic in nature. I've been making a quick review. Today, I want us to specifically look at how to determine the sum of the terms given in a certain series. As you can see, sum of arithmetic progressions the formula for the sum of the n terms of n AP can be derived as below. Can be derived as what? As below. Now, I'm not going to quote for you that formula. I want to derive it such that you can see where it comes from. Consider the series below. Consider the arithmetic series below. Arithmetic series below. Consider the arithmetic series below. We have A plus D. If this is the first term, to generate the next term after this one, we add on what we call the common difference. So the next one will be A plus 2D, the next one will be A plus 3D, up to A plus n minus 1 into D, up to n minus 1 into D. This one is our last term. This is a finite series. Now, what if I also rewrite it as A plus A, or it can be A plus D plus A plus 2D plus A plus 3D plus, now this is A plus n minus 1 into D. I've called this the last term. So the term before this last term can be A plus n minus 2 into D. This is the term before. This is the last term, but the term before it is this one. If this is the first term, the term after you keep adding. Here I've just subtracted going backwards. That's why you're seeing A minus, so A plus n minus 2 into D. Now, instead of A plus n minus 1 into D, if I use L to represent the last term, then my series is going to be A plus D plus A plus 2D plus A plus 3D plus up to, now I've called this the last term. I can place it there. I've used the L instead of this. So the term before the last term, because L is my last term, the term before that last term is L minus D. That one is L minus what? D. So therefore, S, that S is standing for the sum. S is given by A plus D plus A plus 2D plus A plus 3D plus up to L, which is the last term, then plus L minus D. What if I rewrite it in the reverse order? Reverse what? reverse order. What if I write it in the reverse order? I'll have my S is equal to, reverse order means I'm now starting with the last term. So I'll have L plus the term before it is L minus D plus L minus 2D plus L minus 3D plus, now this one is the first term, it is the one I'm starting with. After the first term, I'll have A plus D. I think that. If I call this one here equation 1, I will call this one equation what? Equation 2. I have two equations, both in S, the sum of these ones, and writing them in a reverse order. I have something like this. Now, I can now add equation 1 and equation 2. If I add 1 and 2, because if I add S to S, I'll get 2S is equal to, now there is something you're going to see, some magic is going to come in. I can group this one with this, because this is my first term in the first summation, and this is my first term in the second summation. Remember, I'm adding them vertically. If I add this to this, I'll get A plus L, then plus. If I add this to this, I think that grouping, some magic is coming. If I add, I have A plus L, D plus negative D, that one disappears. Still, this one will give me A plus L. Plus, it will be the same case here. I don't know whether people are following. It will be the same case there. So I'll still have A plus L, and so on. It will still come here. You add this to this, you still have A plus L. Even if you add this to this, you still have A plus L. So what does that mean? What that one means is very simple. You have any number of A plus L terms. If I'm to add up all this, I'll end up with 2S is equal to n number of A plus L terms. Why? There is a term A plus L here. After adding this to this, the same cases are happening here. So I'm having any number of A plus L terms. So therefore, I'm interested in S. That S is going to be n into A plus L over 2. Where n is the number of terms, A is the first term, and L is the last term. And L is the last term. Now, what if I interchange my formula and I give it in a different way? Or, since L is A plus n minus 1 into D, my L is the last term. I can replace it with this. Remember, we say that that term generates the last term, or that's the formula for the last term. So my S is going to be n into A plus n minus 1 into D all over 2. And if I simplify it further, this S is n into 2A plus n minus 1 into D over 2. You close the brackets here. So these are the two formulas. Here, the only thing that is coming in is the D. That D is the common difference. That D is the common difference. So, that D being the common difference, I have two formulas for the sum of the arithmetic progressions. If you're given an arithmetic progression and you asked for the sum, you can either use this formula here, this one here, or you can use this depending on how you want to use them. If you're given the last term, you can go straight and use the other one, or you can use this one. Both formulas will give you the answer as you need it. So from there, we need to look at a questioner list and apply that formula. Example. Example, in an AP, the 13th term is 27, and the 7th term and the 7th term and the 7th term is 3 times the second term. 3 times the second term. Find the common difference. Find the common difference. Find the common difference and the sum of the first 10 terms and the sum of the first 10 terms. There we are. We have a question there. Let's look at its solution. Now, they have said in an AP is the short term of arithmetic progression. In an AP, the 13th term is 27, and the 7th term is 3 times the second term. Find the common difference and the sum of the first 10 terms. Now, from UN, which is A plus N minus 1 into D, I said it can be used as the nth term, and it can also be used as the last term. In this case, we are going to use it at the nth term. So we have U13, meaning 13th term, is equal to A, we don't know A, plus N, that is 13 minus 1 into D. So, but I have told us that this is 27. So therefore, we have A plus 12D is equal to 27. Very important to note there. Then they are also saying that the 7th term, U7 is, the 7th term is 3 times the second term. This is very important. They have told us, and the 7th term is 3 times the second term. I guess we can get something from here. You call this one equation 1. You call that one equation 1. Now, our U7, using this, we are going to have A plus 7 minus 1 into D is equal to 3 into A plus 2 minus 1 into D. 2 minus 1 into D. So, ladies and gentlemen, ladies and gentlemen, we are going to pick it up from there in our next lesson.